Okay, so today we combined all of our skills that we've had so far with solving polynomials. So graphing and factoring and dividing and all these different ways that we can use to find the roots of polynomials. We combine them all, and we're going to use that in order to solve polynomials to find all of the zeros, real or non-real. So this is going to be number 8 from your homework assignment 12.1. So our first step, if we remember, is to graph the thing. So we type it into Desmos or into your graphing calculator, and we can graph this. So when we do, we see that it touches the x-axis right there. And then this side just continues up. This side levels off at a point and then continues up the other way. So there's what our graph should look like. And notice this right here is at the point 1, 0. Okay. So in this graph, we have one real zero. And it's at x equals 1. But really, if we remember from class, when we have ones that just touch the axis like this, where the equation, just rests there for a moment, that counts for 2 of our zeros. So in this case, if we were to factor this thing, x minus 1 would be a factor 2 times. So x minus 1, and also again, x minus 1 would be a factor. So if we go to use synthetic division to divide this out, we're going to have to divide out 1, or x minus 1, twice. So to start with, let's do synthetic division. You can do long division if you like. Either way, you'll just divide this top equation here by x minus 1. I'm going to use synthetic since it takes up less space. So here we have 1 in the box, and then our coefficients are 4, -8, 5, -2, and 1. So we bring down the 4. 4 times 1 is 4. Then adding these together, we get -4. So -4 times 1 is -4. Adding these, we get 1. Multiplying, we get 1. Then -1, -1, and 0. Okay. So then we have to bring it down a power. So this is going to be x cubed. This is going to be x squared. X, and then our constant term. All right. So since x minus 1 is a factor twice for this, that means that we have to take this, since it's still not a quadratic, which is where we want to get it, we have to take this and we have to divide it again, and we have to divide it by x minus 1 again. So we're going to put 1 in the box, and then we're going to use these coefficients to divide again. So we're going to have 4, -4, 1, and -1 this time. So we bring down the 4, and we multiply. We get 0, and 0 times 1 is 0. 1 times 1, and then -1 plus 1 is 0. So now we're bringing it down a power from this equation, and this was a cubic. So this is going to be x squared, and then we have 0x, and then our constant term, and then there's no remainder. Okay, so once we get it down to this format where we've got it as a quadratic, that's where we have to take it and plug it into the quadratic formula in order to find our imaginary zeros. So A is going to be 4, B is 0, C is 1. So plugging this into the quadratic formula, we should have -b, so -0, which isn't really a thing, so we just use 0, plus or minus the square root of 0 squared, minus 4 times a, which is 4, times c, which is 1, all divided by 2 times a, so 2 times 4. Okay, so now we have to simplify this. The thing under the square root here is -16. And then we don't really need to keep the 0 because adding or subtracting 0 doesn't really do anything. Doesn't change the value of the function or the equation, but we do need to keep the plus or minus because we still do have both of those. And then 2 times 4 is 8. Okay, so now we just need to simplify this. The square root of 16 is 4, and the square root of -1 is I. So we have plus or minus 4i divided by 8. And then to simplify that further would just give us plus or minus I over 2, because both of those are divisible by 4. So that is our other 0, or are our other zeros. So we have positive I over 2, and we have negative I over 2. So here, at adding to our collection of zeros, we have plus or minus I over 2. So now we have all three, we have all three of our zeros here. 1 and plus or minus I over 2. And remember that the 1 was a factor twice, so that counts for 2 of our zeros. So we have a total of 4 for our quartic. So there's all of our zeros.